Welcome everyone to lab number 22 on time series analysis with Amazon SageMaker. Indeed, Amazon SageMaker is now the new service used in AWS for time series analysis, as opposed to Amazon Forecast, which was the previous service used for time series analysis. But we're going to check today, indeed, before we start with Amazon SageMaker, that we can't use Amazon Forecast anymore. It is deactivated. They just terminated the service. Let's check that right away. I'm going to share my screen. And please confirm if you can see my screen. Can you see my screen? You should see an infinite mirroring screen.
Then yes.
Yes.
Yes, perfect. Okay, sorry about that. So welcome to the console home. As we said, the first thing we want to check is that forecast does not exist anymore, or maybe it still exists, but yes, it still exists, but normally it is terminated. Amazon Forecast is no longer available to new customers. Existing customers of Amazon Forecast can continue to use the service as normal. Okay, so it's for new customers. So I'm curious, can you see it in your console, Amazon Forecast? If you're an existing customer of Amazon Forecast, meaning if you used it before, then you should be able to see it like me. And of course, me, I used it many times before. Actually, we already did 2 labs on time series analysis with Amazon Forecast, which is why I can just use it like before. Okay, but that's good to know. However, if you have never used Amazon Forecast before, well, you should not even be able to find it in the search bar. So let me know, are you seeing Amazon Forecast in the search bar?
Yes. Whether I can use it is a different question.
Okay. So just so you know, if you already used Forecast before, then you will find it and you can use it again just like before. If you never used it before, you can't use it and you have to use the new, official service for time series analysis, which is Amazon SageMaker. Okay? All right, so let's go back to the console because this lab is on Amazon SageMaker. And let's enter in the search bar SageMaker, then AI. Make sure to take this one, Amazon SageMaker AI, and not Amazon SageMaker. All right, so Amazon SageMaker AI, this will take us to the SageMaker AI service in which we can do machine learning, of course, time series analysis, time series prediction, and many other AI applications actually. And our first step will be indeed to create a domain. So we click the Create Domain button here, and then we're going to choose this option, Setup for Single User, Quick Setup. We click Setup here, and this will create not only a domain for us, but also a user from which we will launch the Canvas app. You will see. Preparing SageMaker domain, please do not close this browser tab. Okay, so that will be the domain settings containing all the settings of your domain, and this is what will contain the user profile. So far it is not created, but as soon as the domain is created, and it is being created right now, well, we will see a user profile. Okay, so let's just wait for a couple of seconds, and as soon as our domain is ready, I'll show you the user profile. All right, the SageMaker domain is ready, and so now if we go to user profiles, you will see our user profile right here, from which, as I told you, we can launch different apps. And the app that we're going to launch is, of course, Canvas, because that's from Canvas that you can do time series analysis, as opposed to Amazon Forecast before. So now it is redirecting us to our domain, but from which we launched the Canvas app. And here we go. Here is the Canvas app, Amazon SageMaker Canvas, creating application, as we just did, when we launched the Canvas application from our user profile, assigning infrastructure resources to power your Amazon SageMaker Canvas application. The application uses these resources to enable you to analyze data, prepare and modify dataset, view data insights and visualizations, preview model, run what-if analysis with single predictions, or generate bulk predictions to derive insights. To release your dedicated resources, you can use the log out button within the Canvas application. All right, so now it is, as you can see, creating the application. It will just take a couple of seconds, and then we'll be ready to start building. There we go. Our model soon, our time series prediction model. But first, what we'll do is actually to import the data set, which you will find in the lab post. Okay, lab number 22 on time series analysis. All right, so, well, let's do this immediately. Let's do the first step. which is to go to the datasets here, because that's where you can import datasets in Canvas. These are just sample datasets you can play with, but we have some real world data for our lab 22. And so here we go. Let's click the import data button. And then of course, we're going to choose here among the dataset types, tabular, because our dataset is contained in a CSV file. So how are we going to call our dataset? Well, we can call it demand forecasting, because it will consist of predicting the demand, the sales of some products in some retail stores. So demand forecasting makes sense. Let's click create. Okay. And then the beauty of Canvas is that we don't have to import some data from S3. We can directly import them from our computer. And so we can click this button here, select files from your computer. And then we're going to go, of course, into our live lab number 22 datasets folder, of which you can find the zip folder in the lab post, lab number 22 on time series analysis. And inside this live lab number 22 datasets folder, you will find 5 subfolders: tiny data, which contains the historical demand over 1 year of 3 items in one store; the small data, which contains the historical demand over 5 years for 3 items in one store; the medium data, which contains the historical demand over 5 years for 50 items and in one store still; then the big data, which contains the historical demand over 5 years for 50 items and in 10 stores this time. So here we have another dimension, we have an extra dimension compared to these 3 first data sets. And then the huge data, which contains the historical demand over 5 years for 50 items in 10 stores, but which will have separately a training set and test set. As you can see, that's the training set and that's the test set, which therefore is even bigger than this big data, which is why I called it huge data. Okay. But for educational purposes, and so that our model doesn't take ages to train, we're going to work on the small data, which is still good. You will see it will still take quite a bit of time to train, because indeed our time series prediction model that we will build in Canvas will have to understand the time series correlations over 5 years for 3 items in one store. Therefore, the 2 features will be these 2. Okay, and the target will be, of course, the sales. You will see I will import that data set right away. So you just select it, demand forecasting.csv in the small data folder. Then you click open, and we will get a preview of this data set, and you will very well understand what this is about. It contains 3 columns, as you will see. The first column is item ID. So remember, in this small data folder, we have 3 items. Therefore, we'll have 3 item IDs, 1. And if we scroll down more, which we can't because it's previewing only the first 100 rows. But if you scroll down more in the original dataset, you will see item ID number 2 and item ID number 3. Then we have timestamps here. So don't worry if you don't recognize the timestamps as in the original dataset. That's simply because we have an automatic conversion by Canvas. Okay. But if we look indeed at the original dataset, right? Lab number 22, small data, and demand forecasting. I can open it with a text editor like Sublime Text because I'm on a Mac. Here it is. That's the data set. Let me see if I can zoom a bit. Yes, there we go. Much better. Okay, so as you can see, there are 3 columns: item ID, timestamp, demand, just like we saw in Canvas. But in the second column, the timestamp, as you can see, these are readable timestamps. We can understand here that it is the 1st of January 2013, 2nd of January 2013. And if we scroll down, by the way, I can also show you item ID number 2. Here we understand that we are for item ID number 2 and 11th of November 2014. Okay, if I scroll down more, we are here 29th of December 2015. Okay, if we scroll down more, we will have the historical demand for item number 3. Okay. All right, I can show you a bit. 17th of March 2015. Okay, so that's the original data set. But indeed, in Canvas, well, we do have an automatic conversion of the timestamp. It's like an encoded timestamp. Okay, so don't worry, we will see the original format of the timestamp back later on in further steps when building the model. Okay, so that's all good here. Don't worry about this encoded timestamp. We can create the data set. Okay, great. Now it is processing and ready. Perfect. And so now we can move on to the next step, which is to build the model. And to do so, you go to My Models within Canvas. My Models, loading, and here it is. That's the process we're going to go through to build our model. So first we will build a model, then analyze it, then make our predictions, and then deploy it. But we won't go up to the deploying step. This is for when we want to go into production phase, but of course, this is out of the scope for this lab. So we'll just go up to the predict step. We'll do these 3 steps, okay? So here we go. Let's click plus create new model. We can call this model time series prediction, okay? Or time series analysis for demand forecasting, whatever you want. Then among these 4 options, predictive analysis, image analysis, text analysis, or fine-tune foundation model, of course, we're going to choose predictive analysis. And then we're going to click create. Perfect. Loading. And we're going to proceed with the first step, which is to import, of course, the data set, right? We first imported it in Canvas, but now we have to import it for our model. So of course, we choose this one, demand forecasting. And then we click select dataset. Okay, and here we go. We are in the build step. Okay, so here we have several things to do. Very important. The first step is to select the column to predict, meaning the target column. Okay, and of course, the target column, the variable that we want to predict is the demand. We have the historical demand over 5 years from 2013 to 2017, for every day of each year. But we will want to predict the demand for the next year, 2018. Okay, so that's our target column. And so here I'm going to choose, of course, demand. All right, so that's the first step done. Good. Then the next step is to configure the model type. So as you can see, Canvas already detected that our model is a time series forecasting model, which is good, right? If you do, for example, machine learning, to build a regression model or classification model, it will also automatically recognize regression or classification. But here, because of this timestamp feature, well, it automatically recognized that we are doing time series analysis. So that's good. But then we still need to do some more configuration. So here we're going to click configure model. Okay, so model type, all good. It recognized that we are doing time series forecasting. Good. So we keep that option, time series forecasting recommended. Indeed, a time series forecasting model uses past data values to predict future data values. So now we're going to move on to time series configuration. Choose the column that uniquely identifies the items in your dataset. Of course, that's going to be item ID. But if we try to click item ID here, you see that we can't select item ID. And that's because it says item ID must be text data type. Okay, no problem. Let's cancel this. Let's look at our columns here, as you can see, and especially item ID, because that's what we're just trying to select. As you can see, for item ID, the data type is numeric, and Canvas requires that it is actually text. So you click text here, and this gives you a nice visualization of your different variables. But then, in order to validate that we want the new data type of our item ID feature as text, well, we have to click add here. Okay, so now it's basically saving the item ID feature as text. Okay, change data type to text in item ID, done. Okay, good. Now let's go back to time series prediction, V1. Meaning our original dashboard where we left things, and there you go. Now item ID has the right data type, meaning the data type expected by Canvas, text. Okay, good. So now let's go back to configure model. And now we will be able to select our item ID column. There it is. Item ID, we can now select it. Good. Now choose a column that groups the forecast by the values in the column. Well, that's completely optional. We don't have to do anything here. This would be useful if we wanted to group, for example, the forecast by the different stores. All right, but here we're working with the small data. Therefore, we don't have the stores. But if you want to play with the medium-sized data, well, you can definitely add this. Okay, then choose the column that contains the timestamps. Well, it's already selected. It's, of course, timestamp. And specify the number of days you want to forecast into the future. So as we said, we would like to
predict the demand of the items in the store over the next year, meaning over the whole year of 2018. And so we're going to forecast the demand of items 1, 2, and 3 over 365 days, okay? So that we can get the demand predictions of items 1 to 3 for all 2018. Good. And we won't use any holiday schedule. That's fine. It will catch anyway the seasonality. Okay, then the rest is advanced. We could, if we wanted, specify an objective metric, but we're going to keep this. This is anyway a good one for time series analysis. Algorithms, well, interesting. It's going to use all these algorithms, to make this master time series prediction model. So, wow, we have a convolutional neural network with quantile regression, recurrent neural network, deep AR+, Prophet, of course. That's an open source algorithm based on an additive model that works best with data with strong seasonal effects in several seasons of historical data. But Prophet is actually well known and widely used for time series analysis, so good that it is included. Autoregressive integrated moving average, excellent. Amazon forecast, there you go, still taking the Amazon forecast original model, non-parametric time series, and exponential smoothing ETS, excellent. Well, it was good that we checked this. I'm glad that you know what we're using, behind the scene. And then forecast quantiles, yes, that's the regular forecast quantiles that are used in common practice. 0.10, 0.50, the median, and 0.90. Okay, so very good. Let's just check that we still have the chosen configuration. There we go, perfect. So we can click Save. And there we go. So now, as you can see, we're still not ready to build our model. I can see that because I can't click this button. It's supposed to be blue. So what does it say? The column names, timestamp in the dataset are invalid because they are reserved keywords. Change the column names and ensure that the column names begin with a letter and contain only letters from A to Z, lowercase or uppercase, numbers, space, or underscore. No problem at all. Basically, we can't use timestamp. It's a reserved name, a variable. But that's okay. We can just, as you can see here, double click to rename, double click on the variable, and well, let's just put, I don't know, a little underscore between time and stamp, okay? Or you can recall it however you want, but this is all I'm finding to rename this reserved timestamp name, okay? We can still not build our model. This time, what does it say? You must configure the time series model before building. Okay, so we had to change the variable name before, so we have to configure the model again. There we go. Let's do it quickly. Item ID, that's well selected. Timestamp column, yes, of course, because we changed the name of the timestamp variable, well, we have to select it again, timestamp, okay? All right, now it must be good. Let's just check that we have still the right model type. Yes, time series configuration, all good here, 365 days over which we want to predict the demand, meaning for the whole year of 2018, because the last year of the historical demand in the dataset is 2017. You can even check that the last row is 31st of December 2017. Then objective metric, yes, the same one. Algorithms, all these ones. And forecast quantiles, the three same ones. Perfect. So let's click Save. And now we should see it in blue. There we go. Standard build. We can now finally build the model. And so just so you know, if you used Canvas before, you can't do a quick build here. As you can see, quick build. To enable quick build, days in the configure time series model dialog box should be at most 30. Yes, okay, but that's too low. So we're going to keep standard build. And there we go. We have everything ready to now build our time series prediction model. So let's do this. 3, 2, 1, and standard build. Validating your data. Yes, the data is fine. We did the right changes. We made the right changes. Now it is pre-processing our data set. It will take a few minutes indeed. And then you will see it will actually take a lot of time to build and train the time series prediction model. It actually takes 1 hour. If I remember correctly, when I did it myself, it takes at least 1 hour. So we'll have to wait a little bit here. You can navigate away from this page and this won't interrupt the process. Yes. And there we go. Build a model. Yes. Model overview. Your model is being created. Standard build usually takes between 1 to 4 hours. Well, that depends on the dataset, of course. But as you can see, the expected build time is 2 hours. Okay, so let's hope it's not going to be 2 hours, but I estimate it's going to be between 1 to 2 hours. Build type, standard build, detailed progress, pre-training. And then you will see it will have the other steps of the whole training. You can watch it if you'd like, but just know that it's going to take some time. So now let's just wait for this training to be done, and I can't wait to see you again as soon as the training is over. See you in a couple of, well, dozens of minutes. All right, as you can see now in the detailed progress, we moved on to the next step, training models. So we're done with the pre-training and we are now training the different models that I showed you. Remember, Prophet, convolutional neural network, deep AR, all those models are being trained now, and then they will form a team that will make the prediction through a voting system. Okay, so it's like an ensemble model in machine learning, as we saw also in our cloud AI courses. Okay, so there we go. It is actually the step that will take a lot of time, and now 10 minutes of training time have passed, and let's see how long it's going to take in total. So I'll see you in a couple dozens of minutes. And here we go, the training has just finished. It actually took almost 2 hours on my side. Let me know on your side how long it took for you. But there we go, it was a long training and we end up with an average weighted quantile loss of 0.088, a mean absolute percent error of 0.174, a weighted absolute percent error of 0.138, a root mean squared error of 7.092, and a mean absolute scaled error, be careful, it's not squared error, it's scaled error, of 0.654. So we got pretty good results eventually. Remember that this was the main metric of performance, and indeed that's a very good one for time series analysis. So we can be pretty confident of the results. And well, that's it. For the analyze step in time series analysis, you will just look at those metrics of performance. You won't have a visualization dashboard like what you can get with machine learning when doing, for example, regressional classification. Indeed, there are no features that impact the accuracy scores. So we're basically done here. We just had to check that we got indeed a good average weighted quantile loss, okay, which I remind evaluates the forecast as a whole by averaging the accuracy at specific distribution points called quantiles for P10, P50, and P90 quantiles, as we had indeed in our configuration by default actually. A lower value indicates a more accurate model. So as you can see, it is pretty low, which means our time series prediction model is potentially accurate. All right, so let's move on to the next step, the last step actually, because we won't do any deployment. Predict, okay? So that's actually the fun step. We won't do batch prediction because for this we need another CSV file of new dates in 2018. So we will just do single prediction. We'll just play with different values. And so for example, well, first let's choose the item of which we want to predict the demand in 2018 for some specific days. So let's choose to start with item number 1, then we'll do item number 2 and 3 if you want. Generating predictions, model is redeploying. This may take 5 to 10 minutes. And yes, we will actually have not only the historical demand from 2013 to 2017, but also the new year, the new whole year of 2018 with the forecasted demand, for every day of 2018. Because I remind that our data set, the historical demand that we have are for all the days from 2013, from January 1st, 2013 to December 31st, 2017. Okay? So let's just wait for this model to be redeploying. As you can see, it may take 5 to 10 minutes. So let's just wait a couple minutes and let's see the forecasted demand of item number 1 in 2018 for every day of 2018. All right, done. And we get the forecasted value, as you can see here in the y-axis, over actually the last days of 2017. So that's still part of the historical demand here that we had in our data set, right, up to 31st of December 2017. And then starts the forecasted values for the whole year of 2018. So that's for January, then that's for February here. And if we scroll to the right, we will see the whole year. So these are all the forecasted values of the demand for each day of 2018. And that looks really, really good. We can see that Our model caught pretty well the seasonality, and yes, it is some very good time series predictions. So amazing job. We have, as you can see, 3 curves corresponding, of course, to each of the 3 quantiles we have, P10, P50, the median, and P90. Okay, so that is P10, that is P50, the median, and P90. Okay, and of course, in blue over there, we had the historical demand. Okay, so there you go. Nice visualization dashboard. And note that you can also download the prediction if you want, either in the form of a CSV file where you will get all the forecasted values of the demand for the whole year of 2018, meaning for each day of 2018, or you can also download an image, which I think will give you this chart. All right, great. And now to finish, let's just do another item, maybe not the 3 of them, but let's do, for example, item number 3, okay? But we will get something similar. All right, so model is redeploying again. Let's just wait for another 5 to 10 minutes, or maybe not. As you can see, it says may take a few seconds, and yes, well, actually, let's do the 3 of them then. But there you go, same. We have first the historical demand for the last days of 2017, and then all the forecasted demand for the 3 quantiles, P10, P50, and P90. And again, the seasonality is very well cut, so it seems accurate predictions. You can even play and compare with the historical demand over an older period. You know, we only have the last days of 2017 here, but if you want, you can see the chart over the different years from 2013 to 2017. Okay, and as I said, let's do the last item, item number 2. Here it is, and it will take a few seconds. Indeed, the redeployment was only for the first one, but it actually made it ready for the other 2 items. And there we go, historical demand, and then the forecasted demand with the 3 quantiles. All right, so that brings us to the end of our time series prediction model building and training process. We won't do the deploy step, but just so you know, you can just deploy your model here. But again, that's out of the scope for this lab. Okay, so now time for the cleanup. Please stay with me. It's very important that you all do the cleanup with me until the end. Otherwise, you will get charged. So please do all the steps that I'm about to do so that we're all safe with our money. Okay, so let's do it efficiently. The first step we have to do is to delete our model here by clicking the 3 vertical dots here and then clicking delete. Okay, then you click delete again and bye model. Okay, the model is deleted. Now let's delete the datasets that we also imported. That's an optional step, but still let's do a complete cleanup. So I'm selecting the dataset demand forecasting and I'm clicking delete here. All right, delete it. And good, we're now done with Canvas. Nothing else to do in terms of cleanup within this Canvas app. This is the Canvas app, remember? So let's just log out. And now we're going to go back to the SageMaker AI console where we will do the rest of the cleanup. Remember, we have to also delete the user profile and then, very important, the domain. If you don't delete your domain, you might end up the month with some high charges. That's why I'm telling you, please stay with me and do these steps with me. Okay, so that we can close, that was Canvas, and here we go. So back to the SageMaker AI console. I'm in my domain, which is this one, and I'm in the user profile tab, and this is my user profile. So in order to delete the user profile, you just have to click it. Okay, you click your user profile, and then very simply at the top right, you will click delete. Okay, yes, delete user. You enter here delete, and you click delete. Okay, user profile default, your user profile has been deleted successfully. Perfect. And now, well, it's still here, but let's refresh to see if it's really deleted. If we saw that in green, that means it's usually good. Let's just check that we don't have a user profile anymore here. Yeah, there we go. No user, perfect. And so now we can delete our domain by going back to domain settings. And then very simply, we're going to scroll down and we should see at some point the way to delete it. There it is, delete domain. So you click delete domain here. Yes, delete my domain, delete. You enter delete here and you click delete. You see, it's quite simple. And done. Wow, it's actually much faster than before. It used to take longer to delete a domain. So that's perfect. Now we're all good to go. We can even do some quick checks here. Sometimes there are some things left here. Let's just check algorithms. All good with algorithm. Training jobs. Yes, you see? So these are all the training jobs, and actually you don't have to delete them. So that's all good. They will disappear at some point, but don't worry, they don't incur any charges. Inference, let's see, for example, endpoints. Sometimes we have to delete things in endpoints. Endpoint configurations, yes. Make sure to delete this one as well. You go to endpoint configurations in inference, okay? You select it, and this one you have to delete. Actions, yes, delete, okay? Delete again, you click delete again, and success. Good. Batch transform jobs, that should be fine because we didn't do any batch predictions. And models, we did indeed. It's still appearing here even though we deleted the model in the Canvas app. But let's delete it again here by selecting it, clicking actions, and delete. You see, it's always good to check everything, right? All right, so let's click this to indeed permanently delete. All right, success, you deleted model, and now I think we're all good. Compilation jobs, no, yeah, all good. All good. So remember, to recap, you have to delete in models and in endpoint configurations. All right? Good. So, processing jobs, yes, all good. Yes, we're all good here. We can now go back to the console, and we have two last steps to do in order to really do a full and complete cleanup. You will see that some resources were created in S3. So you go to the S3 service, which you can also enter in the search bar if you don't have it among your recently visited services. So you go to S3 and you will see that 2 buckets related to SageMaker were created. Okay, so we have to delete them as well. Here they are, SageMaker Studio, SageMaker US East 1. So let's delete them both. Let's just check if it is empty or not. Yes, so the first one is empty, so we can directly delete it. So I'm gonna select it and then click delete. Okay, you click delete here. To confirm deletion, you enter the name of the bucket. So you take this. All right, you copy it, you paste that here, and you click delete bucket. Deleting bucket, and successfully deleted the bucket. Very good. And so now there is only the other bucket left, and I think this one is not empty. Let's check, let's go inside, and yes, you see there are 2 Canvas folders, corresponding of course to what we did in our Canvas app. Okay, so back to our bucket, let's select this one, and because it is not empty, we can't delete it directly, so we have to empty it first. So we click empty here, then we copy paste permanently delete, right? We paste it here, permanently delete, and we click empty. All right, emptying the bucket, good. And then we'll be able to delete it. Successfully emptied the bucket, very good. All right, so now we click exit, and we select the bucket again, and we click delete. Okay, remember, we take the name of the bucket here, we copy it, we paste it here, and we finally click delete bucket. And now you are 100% safe with your money. But again, if you want to do a full cleanup and delete everything that was created during this lab, well, there is one final thing to clean up, which is an IAM, because indeed a role, an IAM role was created for what we did in Canvas. Okay, so let's go to roles, and there it is. You see 6 minutes ago, last activity. This is probably from a previous experience I did in SageMaker. So I'll just delete the one we used. Okay, I could even delete the rest, but I'll stick to this lab. So let's select it. Let's click delete, and we enter the role name in the text input field. So that's the role name. You can catch it here. Copy, paste, and delete. Don't worry, the roles don't incur any charge, but again, it's just for the sake of doing a complete cleanup. All right, and now cleanup 100% done, and that brings us to the end of this lab.
So thank you everyone for attending this lab. Study hard for your exams. I don't know if any of you is working for the exam, but yeah, try to do some practice exams and you'll be fine. We just had a new certified member last week.
Oh, nice.
Yeah. Thank you so much.
All right.
And,
Thank you.
Yes, thank you. Thank you. We all did this together.
Yeah.
All right, thank you guys.
All right.
Bye-bye.
Bye.
Bye.